something called a complex fraction. Now, when you add and subtract fractions, what do you always have to have? Addition, subtraction signs. Thank you very much, Captain Obvious.
Actually, you don't.
Yes, you have to have a common denominator. So, when we talk about having a common denominator, there's a bunch of ways of going about doing this. When you have something very similar or very simple as 2 and 3, the easiest way to get the common denominator is to multiply them together. So my common denominator would be 6. In order to change the 3 into a 6, what'd you multiply it by? 2. Which means you have to multiply the top by 2. And then the other one has to be a 1 times a 3. So if you add those two fractions together, long form, you get 7/6. Sixths, excuse me. It's hard for me to say that I got a fake front tooth, so it doesn't go through that. Yeah, it's great. So what happens though when you have something like this? Let's just make this 1/4 plus 1/6. Do you want to multiply those two together? You would get a common denominator if you multiply them together, but in the long run you'd have to simplify it. So what you would do is you would prime factor it to go that route. Do you guys remember prime factoring? Yes. So this is the same as 1 over 2 times 2 plus 1 over 2 times 3. Everybody okay with that? Now to get the what's called a least common denominator, we write down what they have in common, oops, which is a 2. They both have a 2 in common. And then what's left? And that would give you the common denominator. Remember doing it that way?
No.
That's the easiest way to do this.
I've never seen that happen.
You go through it, the pause right there. That's the easiest way to get what's called a least common denominator. Now, if you look at it then, the fraction on the left has 2 2's, but it needs a 3. The fraction on the right has a 2 and a 3, and it needs a 2.
They have to do it that way.
This is the easiest because what's going to happen here in a minute when we start putting polynomials together, it's easier to have them find factor.
Why do you do that? Like, I don't understand how that works.
What do you mean? What is it missing?
Why do you have only 2 2's and there's 3 2's though?
What do they have in common though?
A 2. So
Right.
why would you have 2 2's still and then not just have 1 2 and 1 3?
Since they have one of them in common, we write it down once.
Oh, okay.
And then what's left over? What I'm doing is I'm getting what's called the least common denominator by using those prime factors. Because if I use all the 2's, then I'd have 24. If I use just one of them, I wind up with 12. Okay. Yes, ma'am.
So the 3 is going with which one of them on that one?
Because the denominator doesn't have a 3. Whereas this one has 1 2 1 3, it needs a 2.
Okay.
Because what you're doing is you're multiplying each portion of those fractions by some factor of 1. I'm multiplying the top and bottom by 3 over 3, which is 1. I multiply the other one by 2 over 2, which is 1. We do a lot of this multiplying by factors of 1 always. We did that with rationalizing denominators. We did that with multiplying by conjugates. It's a very, very common way of doing things. So, no pun intended. So this becomes 5/12 would be my final answer then. Okay? It doesn't change when I have polynomials. When I get polynomials, I ask myself, well, right, and why is that? Yeah. In this case here, you'll notice that they both have the same denominator. They both have the 2x plus 5. So just like you have in the past, if you have the same denominators, all you have to do is just add your numerators, or subtract the numerators depending upon what the sign says. So in this case, since the denominators are the same, last time I checked, x plus 5 is the same as x plus 5. So then you just write it down. Yes, ma'am.
So you always want us to write it as a mixed number?
What do you mean?
Like leave it so like 7, 6, leave it like that?
Yeah, no mixed numbers. The improper fractions, what you're looking for.
Yeah.
Yeah, there's no such thing as a mixed number. There may be 1 or 2 times this entire school year that I use a mixed number, and one will be in the middle of trig. We'll talk about going around the circle a certain amount of times. That's really the only other time that I will ever use a mixed number because it's easier to count,
Yeah.
as opposed to 7 pi over 3. It's easier to do it as mixed.
Okay.
Yeah, mixed numbers are stupid.
Heroes.
So far, so good? All right, well, let's make this more difficult.
Of course.
Why not?
Oh man.
In order to add these, you have to have a common denominator. So I have 5 over 6x squared plus x over 4x squared minus 12x. Which means then, when I go to start writing these things out, getting in the back of my mind, knowing that I'm going to have to hit these common denominators, I'm going to start factoring everything I can, just like we did the past few days. As you factor through the problems, you're going to get your terms. Just like you think about prime factoring, you're writing things in terms of 2s and 3s. I'm going to factor these as well to write them in terms of, well, they're polynomial terms, they're binomial parts of whatever. So the fraction on the left, is there anything I can do there? Not really, correct. So I just rewrite them. Here, there is something I can do. I can take out the 4x, good. Now, excuse me, can I do anything else? What? Yes. On the right-hand side, I can factor out the value of x because this is all one giant monomial. Everything is put together via multiplication. The stuff in parentheses is being multiplied. So I can take out this factor of 1, and I'm going to get 5 over 6x squared plus 1 over 4 times x minus 3. So now I have to create my common denominator. So, bless you. Man, this cough is the greatest ab workout ever. Oh,
Yeah, you're doing it everywhere.
I'm trying it. Merry Christmas. I don't know why you're just sitting in the front row.
Because I can't see.
Oh, there you go. So as I go into this, one, move this up some. I need to start making decisions as far as what am I going to get from my common denominator. And I start with my numbers first. You can do this one of 2 ways. If you're okay with knowing that the least common denominator of a 6 and a 4 is 12, write it out. Or if you want to break it down in terms of prime numbers, 2 times 3 or 2 times 2, you can do that as well. Personally, I hope that you guys recognize some of these because they're not going to be that bad when they're talking integer-wise. So are we okay with just saying the common denominator for 6 and 4 is 12?
Yes.
So I'm going to write down a 12. On the left-hand fraction, I have an x squared. The right one doesn't have it, so I need to write it down. The right fraction has an x minus 3. The left fraction doesn't have it, so I write it down.
Wait, so that was the denominator?
Yeah. It's the same idea as what I was doing earlier. What do they have in common? Well, they have a 2's in common, so we wrote down 2. What was left? A 3 times a 2. And what does that give me? 12.
But then how do you know to just move the x squared and the x minus 3 over?
What else is left?
Just those.
Just those. So if this happened to have an x minus 3, they had that in common, I would have written it down also. And it will build into this eventually. Okay? Yeah.
We just add the top and then we do
We have to figure out what each fraction's missing. So if I look at the fraction on the left, it has an x squared, it has a 6, so you have to think in the back of your mind, how do I turn that 6 into a 12 via multiplication? I multiply it by 2. So it's going to be a 5 times 2. And what else does it need to be multiplied by? Very good. It needs an x minus 3. It's the same principle as the idea of using prime factoring via integers, but I'm talking about in terms of, well, polynomial terms. And I do the same thing for the right fraction. The right fraction has a 4, so what do I have to multiply that by to turn it into a 12? 3. So it's going to be plus, because that's what it says, a 1 times a 3. It has an x minus 3, but it needs the x squared. Yes, sir?
Can you get the new numbers on top of the numerator?
How'd I get those again?
Yeah, like how did you get 2x minus 3 and 3 on the
Okay.
numerator?
Going back to the idea of prime factor. 12 was the 2, 2, and a 3. You all right with that?
Yeah.
This fraction has a 2 and a 3. It needs another 2. So you multiply top and bottom by 2. This fraction had a 2 and a 2. It needed a 3. So you multiply top and bottom by 3. That's where that comes in. I'm just saying it because when I'm talking integer-wise, we know that this has to be multiplication. How do I turn a 6 into a 12? I multiply it by 2. How do I turn a 4 into a 12? I multiply it by 3. That's where it's coming from. Okay.
How about for the top? How do you
What do I do now?
no? How do you know what to put at the top?
What do you mean?
Never mind. Just keep doing it. Yeah.
All right. Now, here's my rule. Never multiply out denominators. You don't need to. There's no reason to. Your denominators tend to wind up being awful.
Well, can't you just go ahead and simplify it?
I'm getting to that part here. What I want you guys to be able to do is just write out your denominator, 12x squared times x minus 3. You do not need to multiply that out. That in and of itself is perfectly fine. All right? The numerators, though, I want you to always multiply out and combine like terms. So I have 5 times 2, which is, so I have to distribute a 10 to the x minus 3, and I get 10x minus 30 plus 3x squared.
Oh, so now that we break that down to 0 or something?
You don't have to. There's no reason to. Because if just so I show you real quick, if you rewrite that in your normal descending order, oops. One of the things you'll be able to tell is if you didn't get the least common denominator, you would then have everything's going to wind up being divisible by 2, or everything's going to be divisible by 3, something along those lines. That does show up from time to time. Or if you ask yourself, what times what is negative 90 that you add together to get positive 10? There's nothing, which means it's a non-factorable numerator. So you're done. What's that? Yeah, so then you know you're done.
But
But
then you also like divide them, oh, never mind. Like
It's-
x squared you divide by 3, but.
Can you simplify over addition? And that's the idea here. What's happening is that your numerator is going to have be like a trinomial or a four terms, or it could be any of those. Your denominator will always be within multiplication. There should be no way to split. If you do this right, you shouldn't have to simplify any further after you get to this point. Hold on.
I don't get how like you don't simplify when it looks like that, but like when we did it before, we like divided like cross the x out.
You can't simplify over addition. We can only simplify like that when there's terms. The numerator is not factorable, so I can't write it as junk times junk. If it was possible that I could factor that numerator where it had like an x minus 3 times something else, then I could simplify it out. But since everything in the numerator is something plus something plus something, I cannot simplify over each one of those. Okay? It's the same basic idea that you can't simplify this. I can't say, oops. I can't do that. Did you fall out of your chair again?
No. I dropped this and then to grab it on the phone.
The same reason why I can't do that, okay? That doesn't work. This is a big, big old sad face, very angry sad face.
It's not killing puppies, so like, what is it killing?
It's not killing puppies, it's killing.
Okay.
Oh, that's
Turtles.
Turtles die.
Kittens die.
I didn't say that. What are you doing?
It's what?
Sarah?
That was worse than like a dog going like a
That's what you asked. Well, turtle enthusiast.
So, let's do this again. Now, just like we did the other day, remember when I made that suggestion to you guys as you were multiplying and dividing? As you were writing the problem down to factor as you were doing it? Do that again. The reason why I would say that is that it just takes an extra step away from the I'm sorry. It takes an extra step away from having to do the problem. It means you don't have to write it down and then factor. As you're reading the problem, you say, hey, what times what is 4 that I add together and get 4? 2 and 2. So what I would be doing is I would write down the problem as this. X plus 1 over x plus 2, x plus 2.
It's kind of like a change, same change, but
Well, it's subtraction, so no. Minus, and how do I factor out x squared minus 4? Yes, sir.
The difference is square, so x plus 2 and then x minus 2.
Very good. I get an x plus 2 and an x minus 2. Now, I have all of those terms written out as basically their prime factors. I've prime factored the denominator, so I write down, what do they have in common? They have an x plus 2 in common. So they both of them have an x plus 2. They both have 1. What's left? Very good. So now I look at each individual fraction. Since my prime factors tell me I have an x plus 2, x plus 2, x minus 2, the fraction on the left has x plus 2, x plus 2, but what is it missing? It's missing the x minus 2. So I have to multiply the top by an x minus 2. The one on the left, on the right, excuse me, has one of each, a plus 2 and a minus 2. What is it missing? It's missing the x plus 2.
Okay.
Again, all you have to do is distribute out the numerator, combine like terms, and leave the denominator how it is.
Why'd you make x minus 2 over?
We get x plus 2 squared.
What are you talking about?
Like, for the x plus 1, you moved it, like, there's an x plus 2 underneath it, but then you wrote x minus 2 next to it.
See how it has 2 of them already?
Yeah.
What is it missing? It's missing the x minus 2.
Why?
Remember how we did this? If this was 1 over 4, and this was 2 over 6. I know it's a bad example. Or let's just say it's 5 over 6, just so we don't simplify. This is 1 over 2 times 2.
Yeah.
This is 5 over 2 times 3. What do they have in common?
The 2.
They have 2's in common. So they have 1, 2 in common. What's left?
The 2.
The 2 and the 3. It's the same thing, but with terms. What do they have in common? They both have an x plus 2. So you write down what they have in common. One of them. What's left? An additional x plus 2 and an additional x minus 2. Same idea here. It was missing a 2 and a 3. So this fraction on the left has 2 2's. It needs a 3. This one has the 2 and the 3. It needs another 2. It's the same exact thing, but in terms of polynomial.
Okay.
Does that help?
Yeah.
Cool.
I just, like, don't get why they have to do that. Like,
It's how you get instead of multiplying them together, if you multiply them together, you'd have to factor something out at the end. This is what we're doing. We're getting the least common denominator by using the prime factors of it.
Okay.
So by getting the smallest value first, there's less work later.
It's like,
Yeah, that's a good way of doing it. You're preemptive simplifying. Yeah, that's a really good way to think of it.
is that the correct word?
Preemptive simplify? Yeah. Preemptive, like you're trying to do beforehand? Yeah. Yep. Like a preemptive strike. You're trying to hit the other guy before they hit you. You're cold cocking them. So FOIL out the numerator. You get x squared minus 2x plus 1x minus 2 minus 2x minus 4. And what I would do here is I would simplify, what?
Why do you have a minus
Where?
2?
I'm foiling.
Oh, yeah.
And what I would do here is I would combine these. Since I know my denominator is not going to change, just simplify it first. I'm going to get an x squared minus 4x plus 1, so it'll be minus 3x minus 6 over. And I heard you say this, look, it's where you said you can write it as x plus 2 quantity squared. You can do that. Or could you write it as x plus 2, x plus 2? Either one's fine. Fine by me, it doesn't matter. It works the same. And you're done. Because if you go back to that, what times what is negative 6, you add together to get negative 3? Nothing. If there was something, that meant that you probably didn't preemptively simplify. If that makes any sense. Okay? That way you're getting less nastiness when you're done. And that's it, you're done. Never multiply out your denominators. There is no reason to. Okay? Yay? All right. Excuse me. Really trying not to die. Working out also.
What the heck?
Oh, you guys and your whining. And the answer is 1.
Yeah.
Welcome to the Wambulance. You guys whine too much. Of course I knew you guys were gonna whine. So
Yeah,
wham.
so you hit
Take
it.
a ride on the Wambulance and like it.
I'm on the gambling.
Hit a ambulance in the nose with sound.
There's this thing on computers called the internet. You know, I could do this for you also. There's this thing called Google. Did you know there's a website called Let Me Google That For You? So if somebody ever, this is, I never go off topic. If one of your friends or one of you trying to figure out how to do something, or they're trying to remember the address or whatever, and all they really had to do was Google it, there's a website called Let Me Google That For You. And if you go to the website Let Me Google That For You, type in what you're trying to Google, and then it gives you a link and you send it to the person, and it pops up. It goes to Google, and it types in what they're asking them and hits enter and says, was that so hard? It's great. It's funny. I use it a lot.
You should use it right now.
No, I'm busy. So anyway, now we're back to the Wambulance. The Wambulance is fun. I want you guys to think of this. This is called a complex fraction. This is nothing more than 2/3 divided by 4/5. It's the exact same.
I don't know how to do that.
Now, this is what we call vertical math, as opposed to horizontal, which would be 2/3 divided by 4/5, which you know how to do.
Wait, is the 2/3 divided by the 4/5 coming from the problem?
No, I'm just showing you that you do the exact same thing.
Okay, because I was worried different.
Oh, you didn't catch all that simplifying? I thought it was quite evident. So remember, a complex fraction is the exact same thing as fraction divided by fraction. It's just written vertically as opposed to horizontally, where you'll have a same change flip thrown into it later on. Which means that you'll have, when you have something like this, you basically have two separate problems to work with.
Could you flip it in?
Not until you get a common denominator.
Right.
So here, what I'm looking at is in the first numerator, and I always split this into, I want you guys to think of this as just basically two problems put together as one. And that's really all it is. The numerator part here, is there anything that I need to do?
Nope.
No. But there's something I have to do here, isn't there?
Probably.
What's my common denominator going to be between an x plus 2 and an x?
Probably 2x, not
It's going to be, well, do they have anything in common?
an x.
Ah!
Could you multiply by like x?
Can't do that because of that.
So could you multiply by like
It's going to be x times x plus 2.
that's
Remember, this is its own term. It's not going to be written in parentheses, but you can go ahead and write it as parentheses if it helps. So that becomes your common denominator, x times x plus 2. Or write it the other way if you want, x plus 2 times x. Done now. So thinking about it, that's going to be our least common denominator. The fraction on the left needs a what? The fraction on the right needs a, you write it out. So what's 1 times x?
x.
Okay. Plus 2 times x plus 2. So in this case, I have my x times x plus 2 is my denominator. I have x plus 2x plus 4, so I get 3x plus 4. I'm just combining like terms. Everybody okay with that? Now, this numerator of, oops, yeah, this goes here. I still have 2 divided by this x plus 2 now. Now is when I don't have to worry about any common denominators for either of those two complex fractions.
Because you could just flip them multiple.
Well, I don't want to flip them right away. I'm going to rewrite it and then I'll flip them.
Okay.
So I know that my numerator stays the same. So it's going to be 2 over x plus 2 divided by the 3x plus 4 over x times x plus 2. Now, if you want to get creative, knowing that you're going to have to flip that, if you want to flip it right away, go for it. But I would suggest don't, just so you don't screw up. Okay? So now you're in a same change flip problem like you did for the past 2 days. You've got to,
Combines everything that we've done?
yeah. So now you wind up with 2 over x plus 2 times x times x plus 2 over 3x plus 4. And is there anything that simplifies? X plus 2's. I can simplify those x plus 2's because they are written as terms. Everything now is written as its own term. You don't have to worry about anything because you're just straight multiplying. When you do that, your x plus 2's will drop out. So what's 2 times x? And you're done. Nothing else to do. I cannot simplify that any further because of the addition in the term of the denominator. There's nothing left to simplify. And there are varying degrees of complexity to these. It's just a matter of just remembering that you're just getting common denominators basically twice a lot of times. Okay? There's not a lot, I mean, yeah, some of them look pretty nasty, and I'll show you. It's this one.
Like 40.
6.
Sorry.
It's not all that difficult, it's just time consuming.
Yeah. And so that looks like a lot of fun, doesn't it?
Actually, it looks pretty easy.
The slight drone of.
Yay.
We're gonna simplify it.
Yeah, Because you think it's so easy.
Like a simple process.
So
Minus and then.
obviously in the numerator, there's nothing for me to simplify right away because I don't have to worry about common denominator. But in the back of my mind, knowing that I will have this same change flip coming up at some point in time, is that a difference of cubes, or sum of cubes, excuse me? It is. Do I need to do that right away, or can I wait? I'll just wait on that for right now, knowing that I'm probably going to have to do something with that later on. What I want to do is I want to write these denominators in their terms, in their factored terms. So it's 5 over x squared minus 16, which means it's 5 over x minus 4, x plus 4, and 2 over, well, what's my GCF here? 3x, very good, and I'm left with then x plus 4. Everybody okay with me on that? What do those two denominators have in common? They have the x plus 4 in common. So let's see, I have 1 over. So I have an x plus 4. I have one of each of them in common. What's left? An x minus 4 and a 3x. So what I'm going to do is, because it's habit for me, I'm going to put the 3x first. X plus 4, x minus 4. That's all of the prime factors of that nasty looking denominator. And I do the same thing I did a minute ago. The 5 needs to be multiplied by what? 3x, very good. And the 2 needs to be multiplied by an x minus 4. Okay. Now, one thing that you'll probably mess up, subtraction. We'll forget that. Negative 2 times negative 4. You'll do the negative x. You make it negative 2x, but you'll probably forget that it's positive 8. Okay. So multiply out your denominator, or I'm sorry, this numerator portion, you're going to get 15x minus 2x plus 8, which is 13x plus 8 over the junk. And now this just comes right across. Oops, plus 64.
Can we go ahead and simplify?
Yes, because now you're already seeing, hey, I'm going to have this plus 4, and I have this x cubed 64. Well, that's the sum of cubes of x and 4.
Yeah.
So what I would do then is I rewrite this as my giant same change flip. I'm going to get 1 over x plus 4, x squared minus 4x plus 16. That's how that factors out. And then I flip my bottom one. To that. And now do you see why I'm saying don't ever worry about multiplying out your denominators?
Yep.
Denominators get pretty nasty looking. But what simplifies out here? The x plus 4s. Got one.
So is the bottom one that always needs to flip?
Yeah, because you're dividing by the fractions. When you rewrite it horizontally, you can multiply it by flipping it. If you want to do that in one step, by all means, go for it. So these drop, and then your final answer then would just be 3x squared minus 12x over all this. And you're done. I mean, and I'm going, and you're done. But yeah, the reason why I'm getting you guys to work a couple more of these complex ones is because we actually solve more equations in the complex form than we do in the regular fraction equal fraction type thing.
So is this gonna be like the homework?
Yeah.
How many from?
I don't know, 8.
Okay, that's not bad.
All right. I think I already posted. Did I already post it? I thought I did.
Yeah, you did.
I did. What were they? It was on, it's in the old book, right?
5, 6, 30, 40,
Was it 32
46.
evens, right?
Yeah.
Is it the old
This
one?
is, yes, this is all old book. I'll let you know if we ever, you guys can just keep saying old book is fine. I'll let you know when we switch back into the new book. There's a couple of things in logarithms that we'll do in the new book because it was pretty decent. If you give me a second, I'll put a picture of it on the board if you guys just want to take a picture of it real fast.
Ugh.